Okay, so what we're doing with this video is we're going to start getting into graphing inequalities. And so we're still graphing with y equals mx plus b. Remember, b is your y-intercept. That's where you start off at your beginning. And m is your slope, and it's rise over run. So there's a couple different things that can happen. The first thing we can have is we can either have dotted lines or solid lines. The way you know the difference between if it's a dotted line or a solid line, remember when we did inequalities and it was either open or closed circles? It's the same idea. This one's open because it's not underlined. This one's a closed line. And so an open line is a dotted line. Okay, so what we're going to do is this equation, all of these equations are y equals x. So for all of them, the slope is 1 over 1 and the b is 0. So they're all the exact same line, but, or at least the top ones are. Those are for the top. But it's the shading and the type of line. So I'm going to start at 0, 0. And I'm going to go up 1 over 1 the best that I can. I should probably zoom in. Can't see. Okay, and so then now I'm going to take my line tool. And this is actually supposed to be a dotted line, so I can't even use my line tool. I'm going to have to just make a dashed line through my points as close as I can. Okay? Same thing here. I do my dots. Up 1 over 1, up 1 over 1. But because it's underlined here, that tells me that it's a solid line. Oh, I totally missed. Solid line. Okay? So open line is just a dashed line. A solid line is a closed line. Okay? So same thing here, except this time it's a negative. M is negative 1 over 1. So I'm going to go down 1. So dots. Again, because it's open, I'm going to do the best I can to make a dashed line. And since this one's closed, it's the same thing, but for this time, it's solid. So that's the difference between a solid line or a dashed line. Okay. The next thing that you have to do is you have to know the difference between shading above or shading below. Now, you don't ever want to say shade to the left or right because that will kind of mess you up and it's not always accurate. You add a shade above and below. Okay, so for this first one, you see how it's not underlined, so I'm going to have to do an open line. So I'm going to do my dashed line. To find the shading, what you do, let's put a color marker. I put my pencil on the y-intercept and I shade above. And so when I shade above, that's above the line. Okay. I'm just noticing our worksheet's wrong. This should say, I didn't change this. This one right here should be greater than. So if yours does not say that, go ahead and change it to greater than. Same thing here. No, this one's right. This is below, but I had my greater one wrong. Okay, so now here, let's look like what it looks like below. So I'm going to draw my solid line the best I can. And it says solid, so that's why it's that. And again, you put your mouse or you put your cursor on the y-intercept and you shade below. So this is the area below today. So above the line or below the line, and I kind of missed. Okay, so same idea here. Again, same typo. This one should say greater than. So it should say y is greater than negative x. So again, I'm going to do my dashed line because it's not closed. I put my mouse on the y-intercept and I shade. Oops, I did the wrong place. It says greater than. I'm going to shade above. So this is why we can't say left or right, because if you look at these two, the top one's on the left side, the bottom one's on the right side, but it's not always left or right. Sometimes it's different, and so you have to make sure that you shade above or below. Okay, and then here's the last one. And again, solid line because it's underlined. I put my cursor, I put my pencil on the y-intercept and I shade below it, and that's this side of the line. Okay. So that's the first basics you have to do, is know whether you're going to shade above or below and what type of line you're going to have. Okay, so here are our directions on solving, which we just did some. We didn't actually have to solve everything was solved, but for solving, remember you always solve for y, and don't forget to flip when you divide by a negative. That's the main place people are going to make a mistake. So we determine the m and b, we graph the line, figuring out if it's dashed or solid, and then we shade. So I'm going to come back to this solution question in a minute. Let's go ahead to your second piece of paper and do a couple of these problems. So remember our problems back when we first started graphing? If there's only one variable, that means it only goes one direction. It's either a horizontal or vertical line. So right here, x is -2. Well, that's on the x-axis, so I'm going to draw a vertical line the other way. And I know it's open because it is an open circle. It's not underlined. And so now this is the only one that you're ever going to shade left and right. And so I'll change this. I have a pencil like you guys. And so now I just shade to the right. You don't have to shade the whole thing. You can just do scribbles like that, as long as I can see. Okay, so now here's another one that has only one variable, so that means it's a horizontal or vertical line. So y is 3 right here. It's on the y-axis, so I'm going to draw a vertical line. And this one's a solid line because it's underlined right here. And so now it says less than, so less than is below, so I shade below. Okay, all right, for this next one, we have to find our m and our b. Remember, our m is next to our x, so our m is 2/1, and our b is -3. So remember, this is our beginning, so we're going to start at -3, and I'm going to count my slope, up 2/1, up 2/1, up 2/1. Keep going until I go off the grid. And again, this is an open circle, so I'm going to do my best to do a dashed line. And then we put our pencil on the y-intercept, which is right here, and this one says greater than. So I'm shading here, and so this is the side. All right, 2 more problems. These ones are a little trickier because you have to do some solving. And so here, I need to move my 2x on both sides. And so I get y is greater than or equal to -2x plus 5. And so now my m is -2/1 and my b is 5. Remember, we started our b, so here's our b. And I'm going to go down 2 to the right one. There's only one negative, so I only go down. I don't go to the left. That would make it a double negative, which would turn it to positive. Okay, it's underlined, so I'm going to draw a solid line. I put my pencil on the y-intercept and I shade above. So it's here. Okay, one last one. We're going to subtract 3x on both sides. I'm going to write it over here. I don't have space. So remember, you got to bring that negative with that 4y. And now I have to divide everything by -4. Well, I just divided by a negative. So since I divided by a negative, I have to flip my inequality. So be careful with that. These 2 negatives here become plus. So it's 3/4 x. And then 8 divided by -4 is -2. So m is 3/4, and b is -2. So again, we start at our b. We go up 1, 2, 3 over 1, 2, 3, 4. I'm going to go down 1, 2, 3, 1, 2, 3, 4. Oops, right there. And so it's a dashed line. And I'm supposed to shade this way because I had to flip it. So I'm going to put my pencil at the intercept and I'm going to shade below, which is all of this area here. Okay, so let's go back up and look at the first page of notes and let's find out what a solution is. So the solution region for linear inequality is in the shaded region. To determine if a point is a solution, just plot it and then see if it's in there. You can also plug in x and y and see if it is true. Sometimes plugging it in is much easier than doing the math, than drawing the graph. Okay, so here, like, this is a solution right here. 3, 2, 3, 2, 0, negative 3. All of these points in the shaded region are solutions. All right, so here, we don't really want to have to graph this because I don't have a graph, so that makes it hard. So what we're going to do is we're going to just do our math, and we're going to plug it in. So x is 4, y is 3. So here's my equation I'm going to use. And for this first problem, instead of an x, I'm going to plug in a 4. Instead of a y, I'm going to plug in a 3. 4 plus 3 is 7. Is 7 greater than 5? Yeah. So this one works. Now let's try this next one. This is x and this is y. So negative 2 plus 7 is greater than 5. So that's 5 is greater than 5. Is 5 actually bigger than 5? It's not. It has to be equal. And because it doesn't have that equal sign, this one does not work. Okay, let's try one more. Again, here's my equation. I have my x value and my y value. So I plug in my x. 2 times 5 minus 2 has to be less than or equal to 8. Well, this is 10 minus 2. So it's 8 is less than 8. And this time it works because it's underlined. So that one's a good. That one's good. Okay, and then let's try this last one. Again, just plugging in x and y. 2 times 3 minus negative 1 is less than or equal to 8. So that's 6 plus 1 is less than or equal to 8. So 7 is less than or equal to 8. And that's true. So both of those worked. So if you are finding solutions, you can either plug in the x and y and see if it's true or false, or you could graph it and see if it's in the shaded region. Remember, when graphing, it's really important to first figure out your m and your b, graph those, then figure out if it's solid or dashed, and then figure out where you're going to shade.